Hi, this is Over and Under Constrained. Your expectations coming into this class where you'll be given a project and it's got a definition of done, it's got a due date. You're discovering that the definition of done is not clear. That's an example of under constrained. Then some of you make an impossible situation. I can't do the project until the materials come in. That's an example of over constrained. But why is perfectly constrained evil? Teachers try to create homework problems so there's just one answer and they can check for the answer and maybe check your work. That's perfectly constrained. There's one answer, there's one path to the answer, and that's what you expect out of education. Suppose you take a test. There's a problem that's impossible to do. And you spend 30 minutes trying to do the problem, thinking it's your problem, and it's impossible. You give up. You learn later that it was truly impossible. Who do you get mad at? The teacher. That's an example of over-constrained. But in the real world, how can you recognize when something's over-constrained? Suppose you're taking a test and you do a problem and you can see 20 different ways to do it. You can see an infinite number of ways to do it. You can see an infinite number of true answers. You go, oh man, the teacher screwed up. No, that's the starting point of all projects. That's the starting point of all of life. So what we call perfect teaching really doesn't prepare us for the real world. This is what's evil about perfectly constrained. You want to celebrate under constrained. You want to find the many different solutions. Find what causes one solution versus another solution. Is that something that needs to be decided? Is that a requirement? It's always messy. Under constrained is messy. But you can apply this to everything. You've often heard it said that it's bad parenting if the parent's sitting there smoking and says, don't smoke. But the opposite true. You don't want to raise liberals. Perfectly constrained is do what I do. Yeah, that's good parenting, that's good teaching, but at some point you have to learn to deal with the real world, to math, to STEM. Okay, so let's apply this to STEM. Here's a math example. X plus y equals 5. X minus y equals 1. Find x and find y. Perfect algebra problem. Let's see. Let's add them together. X plus x is 2x. Y plus minus y is 0. 5 plus 1 is 6. 2x equals 6. X equals 6 divided by 2. X is 3. 3 minus y equals 1. 3 minus 2 equals 1. 3 plus 2 equals 5. Yay! Answer! Give me a A. Now, if you've got any paranoia in you, you're going to say, whoa, that was too perfect. That was set up. I've been conned. There's something fishy going on. There's a conspiracy going on. Okay, let's take the second one. X plus y equals 5. Infinite solutions. Yay! I get up to make up my own mind. Nobody can tell me what to do. Hallelujah! I just added this Catch-22 logo because this is what over-constrained is in the math world. In the math world, you look at this and you go, okay, we already figured out that x is 2 and y is 3. 2 plus 3 is 5. 3 minus 2 is 1. But 3 times 2 doesn't equal 6. This is impossible. There's something going wrong. And then we remember the rule. If you have two unknowns, you can only have two equations. Yeah, in the math world, everything's perfectly clear. This is why some people love math. But then, once you've understood the math, you can go over here and understand this novel. This is one of those really old person novels that you're forced to read in English class and you absolutely hate it. But it's a great description of over-constrained. You know, you're damned if you do, you're damned if you don't. You get stuck between business processes that don't talk to each other and you don't exist. You wonder whether you even are alive. It's that kind of a novel. But that's what happens when you see an over-constrained problem. Another professor wrote an overconstrained problem for a study guide for a test, and I started arguing with him, and he goes, "No, it's not overconstrained." And I go, "Yes, it is. How do you prove that it's overconstrained?" Well, you've got to shrink it down into math. It can't stay out there in the project world or the engineering world. It has to be shrunken down into math so you can prove that it is. Those are tough, but they're usually a mistake on some person's part. Nature doesn't usually overconstrain us. So the assignment is to find a perfectly constrained problem from a teacher and then underconstrain it, or find an underconstrained problem. That's going to be tougher because teachers usually don't make mistakes. So you probably have to take a perfectly constrained problem and underconstrain it and then overconstrain it. So this is a physics example. Here we have an electrical engineering example. The teacher's done a perfect job of it. 11 equations, right? 11 unknowns. If you make R1 right here an unknown, then it's underconstrained. If you make V1 known and R1 known, it's overconstrained, and the problem can't be done. You have 10 unknowns and 11 equations. That's overconstrained. Here's a mechanical engineering example. 2 equations apply, so you can only have 2 unknowns. Here the 2 unknowns are the force here in this person's foot and the angle right here. So that's perfectly constrained. But if you add an angle value, then it's overconstrained. If this 75 degrees right here is turned into an unknown, then it's underconstrained. Here you have a computer engineering example. It's underconstrained. We're assuming that we're following this. This is a robot that follows light, a light following robot. Yeah. So it has 2 motors and it has 3 light sensors. So it has 2 motors and 3 light sensors. And if this is the truth table right here, it's underconstrained. What happens when there's no light at all? That robot stops. Here, when there's no light at all, the robot stops. So here, it's perfectly constrained. There really is no overconstrained. In software, think of Inventor. When it's underconstrained, it's blue. That means Inventor doesn't know exactly where to put the object on the screen. And when it's been perfectly constrained, it turns green. And when you try to overconstrain it, it starts arguing with you and putting error messages on the screen. In the 3D design world, that's called parametric, when it prevents you from overconstraining it. In the conceive section of a project, where you're trying to define exactly what the problem is, this is the big scope picture, and then your requirements are the details. They're like the equations. And you keep going around and around in the circle, revising the scope, revising the requirements until it's perfectly constrained, until there's clarity, until there's a vision of what the project solution is. So the assignment is to find a problem from one of your STEM classes. Don't try to find one from English or history or something like that. Try to focus on the technical stuff. It should be a bit easier. And then underconstrain it, and then you overconstrain it. So you're basically writing 3 problems that you might see on a homework assignment, and then doing them, and then showing that they're under, over, or perfectly constrained.